So again, my name's Tony Sardinas. I'm with GPI. I'm the Corrosion Protection Pursuits Leader. I've been in the bridge industry for almost 40 years. I was a contractor, an inspector, and now I go around the country talking about bridge painting. It was either that or grass growing, one of the two, right? So anyway, I'd like each of the members here to introduce themselves, and then we'll go ahead and get started. Derrick?
Derrick Castle with the Sherwin Company. Derrick Castle with the Sherwin Company, market manager for dedicated bridge and highway market segment for the company. So work directly with DOTs on specification development, QPLs, APLs, and large projects.
Mike Forakis, Titan Industrial, bridge contractor in the bridge painting industry. We're based out of Baltimore, Maryland. We mainly focus up and down the East Coast. Again, bridge painting is our key thing, but we do other bridge repairs as well for bridge preservation. Been in the industry for good over 20 years. It's a family business. Started from a very young age, and still here doing it today. So, thank you.
Nafiz? You good? Yeah, get close to the mic, though.
Okay. Hi, I'm Nafiz Alqasem. I'm with the Maryland Department of Transportation, the Maryland Transportation Authority. I've been with the MDOT for 36 years, 23 years with MDTA, and 13 years with the Maryland State Highway Administration. I've been in the structure section all of my 36 years. I've been dealing with the bridge coding since I've been with the authority for the last 20-some years. I've been working with Tony and a lot of people in the industry. So I pretty much handle the bridge codings program for the Maryland Transportation Authority.
John?
Well, you guys just met me, but Jonathan Moore, Delaware Department of Transportation. I'm the supervising engineer for bridge maintenance and construction, and I've been doing bridge painting projects for probably about 6 years now, and I got voluntold to stand in as DelDOT's NEPCOAT representative, so I do that now too. But
All right, so like I said, there's no presentations here. This is going to be a Q&A panel. So if anybody has any questions about bridge painting, just raise your hand, and I think Nancy and Todd will go around, and you can ask. We have representing here, we have owners, right? We have a contractor, we have a paint manufacturer, so you're going to get all aspects of bridge painting, from a different viewpoint in a sense. So, any questions to start off with?
Yes, question for Jonathan. On your presentation, you talked about the thickness of the finish coat being, 3 times thicker than, per spec. Was there also issues related to the underlying layers, or was it all just issues with the finish coat?
so in that particular bridge, it was all pertaining to the finish coat. We have our inspectors go in and take dry film thicknesses. When they put the zinc down, then they'll do it again when they do mid coat, and then again when they do top coat, because we use a 3-coat system in Delaware. That one particularly was all. There was issues pertaining to the other coats as well, nothing that couldn't have been remediated, but the top coat on went 300% too thick.
Yes.
Kevin with the International Zinc Association. NSBA has been going around the country. They've been looking at a lot of the single coat inorganic zinc coatings. And the problem with the inorganics, we all know that it's a very tight window to apply and you can't overcoat them. But there's also some very good organic zincs out there that you can overcoat and the window is much, much greater. How come the DOTs aren't looking at the organic zincs? I mean, we're using a zinc-rich primer and we're painting over them. But I'm talking about a good organic zinc that actually you don't have to worry about the binder having any problems with the UV. But there's case studies of stuff out there that's working, and I don't know why we're not looking at this more.
Well, I can start off real quick. I know Derrick, you'd probably have a comment or two on that. But typically, your inorganic zincs are used in the shops for new steel structures, right? For the most part, there are a couple states like Indiana and Missouri that use inorganic zincs out in the field, but organic zincs are mainly used out in the field during rehabilitation. So you have two scenarios: new construction, inorganic zinc; rehabilitation or rework is organic zinc. And what you're saying, I think, well, there is truth. They looked into it, and organic zincs are getting better and better performance-wise compared to inorganic zincs. But I think Derrick can talk a little more to that.
So, Kevin, I think your question is really related to using zincs untop coated, correct? Using the zincs as untop coated? Just single coat zinc application. Yeah. Yeah, so there has been a study, as you're well aware. NSBA looked in, and a university looked into single coat inorganic zinc structures. So they're structures that were just coated with a single coat of inorganic zinc. There's 30 some odd of these structures across the country. Missouri has the most of them. They have, I think they have 20 some of the structures that they looked at, and they're performing quite well. So as a follow-on to the initial study on just inorganic zincs, which are ethyl silicate binders, now there's a number of us been talking with NSBA about looking at a second version of the study where they're doing some accelerated testing on inorganic zincs and adding organic zincs, highly formulated organic zincs to the study. So we know that NASA has looked at inorganic zinc as a single coat system for decades. We also know NASA has looked at some organic zincs, and there are some high performers, as you say, that are out there. So hopefully the study, NSBA's publications will find similar results and make them more broad spectrum available to the public rather than the work that NASA has done, which is pretty tight-lipped.
You guys have any comments on it?
We haven't considered the
What-
use of single.
You wanna?
I mean, with us, with the Maryland Transportation Authority, we really did not look into the use of one code system, period. Just, again, like you said, for rehab projects, what I know is we use the oxide system, the one code oxide system for small rehab projects, just when you do like steel plating and what have you. That's the only time we would entertain that. But as far as one code system for a total cleaning and painting job, we haven't looked into that. We're not considering that anytime soon either, so.
And personally, being around this industry for so many years, I think one code systems, if they're applied in a shop where you have a controlled environment, I think that's excellent. I have personally no issues with that. But when you're thinking about a one code system out in the field, having contractors paint at 100, 150, 200 feet up in the air, and just applying one coat of paint and putting all your prayers that one coat of paint will cover the entire surface, I think, there has to be a little more realistic thinking. That's why when I talk to people around the country, when they ask me, why is an intermediate coat so important? Well, an intermediate coat is really kind of like an insurance coat. So you've got that zinc primer, that's your workhorse. But again, we're out in the field. You've got bolts, you have cross frames, you have back-to-back angles, you have complicated areas, lattice, right? And you want to make sure that you have coverage. And that combination of that organic zinc or inorganic zinc, right, and that intermediate coat will give you the better job. And again, it's the insurance coat, because again, you're dealing with winds, you're dealing with a lot of factors that you don't deal with inside of a shop. Just my opinion.
Hi, I'm Chris. I'm with MassDOT. What about two-coat systems? Like you get something shop primed, and then you got to go in the field as a repair product. Is there a second, a two-coat system that might work? A lot of the steel repair I'm doing is like emergency. I got to get them out there. The opportunity to come back and paint it again later is limited at best. Are there viable two-coat systems?
There are certainly viable two-coat systems based on either an inorganic zinc-rich primer or organic zinc-rich primer. We've seen, over the decades, we've seen two-coat systems with the zinc-rich primer and a polyurethane finish coat. We've seen zinc-rich primers with polyaspartic technology finish coats. The latest version is the polysiloxane finish coats. So there's Manufacturers have these systems readily available. Some of them have been tested through the national testing program under AASHTO, and many of you from this area certainly will be familiar with the NEPCOAT qualified products listing, so List C and List D. Those are both two-coat, an IOZ two-coat and OZ two-coat approved list through the NEPCOAT group.
I have also personally used it for Virginia Department of Transportation, two-coat system.
Yeah, the system that he would have used in Virginia would have been on List C. It was the organic zinc and the polyaspartic at the time that, so you've used it, Sir Locke? Okay. So that's the current List C system as well. So Virginia probably has one of the more extensive experiences with two-coat systems. They did a pretty extensive foray into field-applied blast and repaint projects where they used an organic zinc and polyaspartic technology over the last 12 or so, 10, 12 years. And then more recently, they have migrated to the organic zinc and polysiloxane finish coat technology as well.
Yeah, Bill McElhenney, NSPA retired. Regarding the NSPA work on the single coat inorganic zincs, shameless plug here, stop by the booth where there's a display copy of the publication, and you can pick up a postcard that has a URL where you can download a copy and read at your own convenience. But it's out there. There's a lot of good information in the document, and thank you.
Hi, Maxime Zubé from Galvatech 2000. I would like to hear you on duplex coating, hot dip galvanized and top coat on the contractor side, coating manufacturers, and if it's used a lot and what's the benefits and compared to three-coat system or two-coat system.
Anybody want to take that? You're referring to hot dip galvanizing?
Hot dip galvanized.
So new
painted.
structures being hot dip galvanized, then coated?
Over, yeah.
Yeah, so new structures that have been placed out in the field, what's the opinion about top coating?
And, what do you think compared to three-coat system?
Okay. You guys dealt with hot dip?
Hot dip galvanizing, we use that for like ancillary structures, like, sign structures and light poles, but we never use that on a bridge, it's like.
The only galvanizing we've had, I guess, on bridge structures have been the bolts, I would say, on our end.
Yeah.
You know what I mean? Instead of using black bolts, they'll replace them with galvanized bolts, which, as a contractor, we'll usually still do an epoxy solvent wipe to, etch it, and then put a epoxy coat and then a urethane. So it almost falls like a two-coat on that only. Only when it's a black bolt, at that time, we'll put a full three-coat system with the zinc, epoxy, and urethane.
So on a broader perspective, we, as a coatings manufacturer, we have certainly seen duplex coating systems. The original concept of duplex coating system was a hot dip galvanized substrate and then a coating system, a liquid applied coating system placed over the top. Originally, it would be like an epoxy tie coat and then a urethane finish or something, whatever the owner wanted as for a high performance durability finish. As a two-coat system, we've not seen a lot where you have a hot dip galvanized surface and then just a single coat of liquid coating application. Most of the time, most of those, certainly the ones that have been highly successful, seem to have used an epoxy tie coat. So it turns out to be two liquid applied films. There's limited, so polysiloxane it's not necessarily new by any stretch, but the testing to prove it directly to hot dip galvanizing has been limited. I know we looked at polyaspartics direct because of the film build. The polyaspartics were they didn't suffer from outgassing, just their chemistry. So we looked at those, but their wetting properties weren't sufficient to fully wet out and develop appropriate adhesion for long-term performance direct to galvanizing. So the polysiloxanes have been used some. There is some limited test data on polysiloxane direct to hot dip galvanized. It does seem to do better and develop the adhesion. You just don't you don't have quite the film build range with a polysiloxane. So you still get folks interested in an epoxy tie coat to give you the barrier protection for long term.
We have one here.
Again, in our case, we deal with bridges, large beams, large girders, so you can't really hot dip galvanize those. There are limitations. I think it's like, 40 feet long, the kettles that they use to hot dip, so we can't use those on bridges and for maintenance too, later on, And we found that the three-coat system is more durable than, so far, for bridges. Again, I'm not talking about ancillary small structures like sign structures and what have you. But again, for bridges, the limitation of hot dip galvanizing won't work for us anyway when you're dealing with massive girders and massive beams and what have you. I can't hear.
Metallizing. Have you tried any metallizing?
No. Just we're pretty much, it's pretty much either, if it's not weather and steel, it's pretty much a three-coat system.
Yeah, Dick Dunn from GPI. I wanted to ask the two state reps, or the state reps up there, do you guys have the problem that Ben and Dave talked about with the paint confetti chips? And then maybe Tony and Derrick could talk about, was the reasoning behind that, exactly as Ben stated, the dip, the cold heat of the weather, and then why didn't they see it on more bridges, if you could maybe postulate that? So first, did you all see that? And then the other would be, is he right, and why not more?
Did you see that? You weren't here, I don't think. But there was an issue up in Connecticut and Maine where the paint, due to the high and low temperatures, was popping off.
Oh, yeah.
Have you seen that at?
So I can think of one bridge that we actually just completely stripped and painted that had, maybe not to that extent, but the paint came off in large sheets. And it wasn't until he brought that up that it kind of was like, ooh, light bulb. But that one didn't have lead on it. It had been painted in, I want to say 91, and it was stripped down to bare steel. So the lead theory for me there is gone. So I think that was more of just an application error in the 90s, but we did have one that failed similarly.
Half of our bridge inventory at the Maryland Transportation Authority is weathering steel. The other half is probably painted steel. We actually just did what we call a bridge tour on one of our facility, and it was painted, I would say, anywhere between 8 to 10 years ago. We toured all the bridges, just checking the condition of the entire bridge, and the paint system was still holding up pretty good, so we did not have none of that, did not experience any of that.
Derrick, you want to give your?
So, unfortunately, I can't say that this is a unique phenomena. I've seen this across the country and it does tend to follow severe cold snaps. So I think the hypothesis is pretty clear. I think it does the aging of the coating system, the technology, the resin technology, and the leads, the alkyds. Just the breakdown over the years of service, and quite honestly, the relatively low level of surface preparation when the lead coatings were applied in the 50s, 60s, early 70s. Their coating is only as good as what it sticks to start with, and so just the deterioration model over time, and then that cold snap and the rapid contraction expansion of the steel, coatings pop off. So fortunately, I haven't seen anything quite the volume or severity across the country as what happened in the Northeast, in Connecticut and New Hampshire, or Maine. But I certainly think the cold snap is the root cause of the issue that they saw.
And just to hop on to what Derrick said, I also believe, again, just from experience over the years, a lot of bridges back then when they were built and all that stuff, they painted over mill scale. After they came out of their shops, they painted over mill scale, and like you said, Derrick, with alkyd systems. So when you get that outget, after 30, 40 years, it gets brittle and you get those cold snaps. I think that was the issue. There was nothing for that paint to mechanically adhere to when it was first built. So it was only time, but of course, you got 30, 40 years out of a system. It's not a bad thing, but the way it happened, of course, it's never a good thing either. But that happens a lot with overcoating. That's why we talk about overcoating and being careful, because you can resoften that existing coating, and that resoftening can actually stress that existing coating that you've just overcoated, and that also can pull that paint off of that, especially if there's mill scale behind there when they first built those bridges. Now, like Derrick was saying, they're blasting steel, they're metallizing, they're applying, you know, these high-end type coatings. You're not having that issue. But back then, they didn't know, right? And a lot of times they left that mill scale on those structures when they were coming out of the mill.
One quick comment.
Yeah, Ben Foster, Maine DOT. Yeah, that paint system was 50 to 60 years old.
Yeah.
So it did its job for the most part. It's just we're stuck with
Exactly.
environmental issues now.
It all hit at one time, right?
And it may be an interesting thing that is maybe the beginning of a phenomenon for other states where maybe their similar type coating systems are 40 years old.
Yeah.
So might be a good heads up if it hasn't happened.
And that goes back to the design process, right, in the assessment. When you go out there and look at your structures, you want to see if there's still mill scale under that structure. You know, if there's, you know, if it's been blasted. So there's a lot of variables when you look at a structure and you want to repaint it or even overcoat it, but that was just an unusual phenomena to happen. Go ahead.
My name is Bill Balk. I'm president of Zinc Coat. I just wanted to go back to the zinc for a second in terms of the layers. The technology has advanced many, many years ago to today in terms of purity and density. And so zinc certainly has its benefits, but a lot of the products like Zinc Coat, you can put on 1, 2, 3 layers. They'll cure in an hour. So it's a tremendous saving in labor to be able to do that. And if you did want that comfort level, as you were saying, I'm a little concerned with one coat, you can put 2, 3 coats on and still have a coating system of just a one standalone that would give you the kind of years and years and years of protection. One was put on the Biloxi Bridge in Mississippi many years ago, one spanned that lasted many, many years, you know, so zinc does have an advancement if you've got the formulas. But the key is, I would just suggest too, is we need also to look at cathodic protection. It's great to have zinc in a formula, but if it never gets through the binder to the steel, and that's cathodic protection, and it's encapsulated by its binders, the zinc particles, so they can't create the charge, then you can't have cathodic protection. So you have to be careful about what you're looking at in terms of specifications. Are you looking for barrier protection or cathodic protection?
Right. And that's all good points you're making, right? You know, with all that, and there's a lot of coating technologies are building up to get to that, you know, and they have to go through their process of testing and of those different products. And I think, you know, yeah, it's definitely, there's a lot of new products out there. We just got to be careful at the same time that, you know, you can test a product on a small bridge maybe or whatever, something out of the middle of nowhere. You don't want to test products out on something like the Wilmington Viaduct, right, where you're going to have an issue there. So I get your point, and it's understood. Derrick, did you want to?
One more comment
Sure.
relating to the previous.
Okay.
I'm still curious about the mass failures during the cold snap, and I guess I understand an old coating does get brittle and that sort of thing, but was there an investigation, or have you identified, is it a particular type of material specifically that was used, or is it all of the paints of that era? And, you know, I also know that the thicker coating is, the more shear stress you get at the interface. So, you know, is it number of layers? I believe Ben mentioned the possibility of overcoats in some cases. So I'm wondering if any of those factors come into play as to the probability that a given bridge is likely to experience this phenomenon in the case of cold snap.
And there are a lot of variables, right? I mean, there could be how many layers, how many times it's been overcoated. Again, was that structure Has that structure ever been painted before? I mean, when I say painted, total rehab, where they're going in there and abrasive blasting it? Or is there still mill scale under there? Because in a sense, they applied that paint, the old Alkyd systems, over mill scale, and mill scale is a smooth surface, right? So you don't have that mechanical that you would on a blasted surface. That I don't know. I didn't read the report, so I apologize for that.
Call Illinois, they overcoated.
I know in North Dakota, we overcoated some and had that issue with overcoating. We never had it, but you're saying that you did not do overcoating. There was, so it wasn't that, but.
I mean, that's why they've come out with this new technology that, like Derrick was talking about with sealers. You're putting a very thin tie coat on an existing coating system to relieve that stress, not to add stress, or put on systems that have high solvents and low solids. Because then you're reintroducing those solvents to that existing coating, you're softening that coating, and what happens? It'll peel like a grape, and it'll look just like those bridges. Derrick, did you want to? You good? Yeah. Okay.
Yeah, Mohammed Khan from MDTA. I apologize. I have a slightly different question. I don't want to be off topic, but for Jonathan and Nafiz, after these paint and coatings, are you showing improvement in your bridges at the element level for the superstructure, or your entire component rating goes up, or it depends on bridge by bridge? Okay.
When we do painting?
Yeah, after the painting, yeah.
So it would depend on the elements that we painted, but and it would also depend, what kind of section loss you would have on that steel that you painted over too, in my opinion. But for the most part, we're not letting our structures get to the point where we have severe section loss when we're doing these painting contracts. So we do increase the MBI rating after these contracts have been done. Because in Delaware, we don't practice overcoating. We find that it's more cost effective for us to blast down to bare steel and start again. And so that, that's what we do. And then once that's coated, our MBI will increase.
Okay, and one last question, I'm sorry.
Same thing with us too.
Okay.
Exactly.
Sounds good.
A lot of times, we have a lot of consultants here that do the inspections for us. When they report a lot of pitting and minor rust and what have you in the steel beams, we think that if you paint over that, all that goes away. Okay. So we tell them not to report that anymore. So it does raise that, and we do raise the element rating when we coat.
And one thing to take into account there too is also those issues have been noted and documented in our load ratings that we update, every so often it's as required. So, even if that MBI has increased, we've already taken into account that, you may have minor section loss at this one area. So our load ratings would reflect that.
Okay, and one other thing, you mentioned in your presentation that you modified the spec a little bit, especially for the coatings. I know it's hard to predict anything, it's hard to predict future, but are you still expecting that the paint is going to last 30, 32 years, or maybe less, keeping in mind all the environmental constraints we have, the harsh weather and so on?
So I'm actually expecting that we get a longer life than some of the ones that we've been seeing, because it seems like there was a period of time in the late 90s that where all those bridges are kind of failing in terms of paint quality right now. And the one thing that they all seem to have in common, before we started revamping this spec, and we went out with a DFT gauge, a dry film thickness gauge, and measured, and the DFTs are all over the place. There's no consistency in the coating thickness. There's no uniformity in the coating, and I'm really anticipating that, if we're following the manufacturer specifications, their product data sheets, their film thicknesses, and we're repeating that step after step in applying these coatings, that we should experience a much longer life, not the other way around. Now, in return, we're also, our roads are getting busier, they're, heavier traffic, so, there's that to weigh into the account as well, but I do anticipate we get, at least 30 years. That's our goal.
Okay. Thank you.
Same thing here, the lifespan of a coating system is about 25 to 30 years with us. Sometimes if you have bad joints and you have a lot of leakage, you might have to come back and do zone painting. That's about it. But for the most part, we get about 25 to 30 years out of a coating system.
Yeah, I was just going to say, if you have, you got to look at the whole thing, right? Cleaning and painting the bridge is one component, but if you have bad joints, if you have a deck that leaks, that's going to cause that system to shorten its life slightly because you're going to start getting rusting and corrosion around those areas and all that, the joints, which is the worst area, of course, right? So you want to make sure, that, I've gone out and looked at bridges where I've gone and walked it with an owner, and they're like, what do you think? And I'm like, no, you don't want to paint this bridge. You want to fix the decks first and the joints, and then think about painting after the fact. Because they all work together in harmony in a sense to give you that lifelong lasting of the structure itself and the coating.
And if there's one thing I could, add on to that, I know a lot of states have like a bridge washing program, in order to get chlorides and, any, say you got leaking debris from joints and stuff like that. And that'll really preserve your coating. In Delaware, we don't have a bridge washing program, and it's predominantly just because of manpower. So our coatings are kind of just put on and then trial by fire for their lifespan. So, good application process from the start is really what's going to buy us, the most life here.
One more thing, we tried to do the bridge washing program, but for environmental reasons, we have to scrape that pretty quick. It was a lot of environmental restrictions on capturing the water. We just said, forget it, it's not worth it. So,
Yeah, Maryland State Highway Administration back in the early 90s, they used to have a pressure washing contract where they would have a contractor, he'd put out, it'd be a statewide contract where they would pressure wash beam ends, bearings, and the splash zones on through trusses. But because of the environmental issues, they were, I guess the EPA were like, you can't let this water run off, there's oils, whatever. So they actually stopped that program. I thought it was a great program.
I have a couple comments in regards to Dick's question from a little while ago. He was asking if the state DOTs had a similar issue as Connecticut and Maine. So Delaware's, for Delaware's steel bridge inventory, we no longer have any lead-painted steel bridges. They've all been recoated. But over the C&D Canal Bridge, the St. George's Bridge, it's owned by the Army Corps. In the mid-90s, they had that same issue where it was peeling paint everywhere. We have actually news articles in our inspection file for that bridge about it, and it did happen fairly sudden. I'll say within like a 6 to 12 month time frame where it really, it started falling everywhere. I don't know what the cause was. I don't know if there was any real investigation or confirmation back then, but that time frame, I know we did have some harsh winters in Delaware. We had actual a couple back-to-back 24-inch snowstorms, which is a lot for us. We also had some ice storms where, we had like 1.5 inches of ice on grass. I remember actually pulling up on the yard, like it didn't sink, like the ice was carrying the vehicle. So, we don't have any lead paint. One quick comment about the bridge washing. We don't have a bridge washing program yet. We're looking to get into that business. We're working on it, but we do have concerns like Maryland DOT that our environmental section might not allow it. So we'll see where that goes. But I do agree, if we can wash our bridges, it's going to definitely prolong the life of the paint. So.
Good.
I-
I'm sorry. One thing.
Go ahead.
Yeah, good.
No, I just wanted to add, I guess, in addition to the pressure washing, the other thing that we've been doing for State Highway recently has been removing the drain troughs at every expansion joint. And, the jobs come out and it's strictly cleaning and painting, and as a contractor, we go there, we pressure wash the joints or wherever we feel is salts are coming through, give it like a zone of 5-10 feet, and then we blast the structure. But we consider it all done, looks pretty at the end, but we fail to find out that, here we are, the troughs that are caked with dirt and debris and the drains, they're still clogged. So, here we are, you guys just paid for a really nice system, and in return, you're still going to have stuff trickling down on the bearings and causing failure in the future. So maybe something to consider in addition to the pressure washing piece is incorporating cleaning some troughs or downspouts and drains, to eliminate some of that.
Right, because those contaminants will act as an abrasive,
Correct.
taking off layers of paint. I'm sorry, good.
It sounds like overcoating is become less in favor.
Yes.
And because I guess it's been a while since I've dealt with it, but I understood there's a period of time where you have to do that overcoating, while that coat is still in good condition. And what time period would that be? In a 30-year lifespan, what time period would that be, or what tests would you do? Because it sounds like there's mill scale behind it. You wouldn't recommend it.
No.
So in general, is it like, let's wait 30 years and then we're going to do complete clean and paint? Is that the kind of approach that agencies are doing?
Yeah, it's when you go and evaluate your structures, right? So you want to see what kind of percentage of rust you have, right? Is it isolated? Is it scattered? And then also when you think about overcoating, you want to see how thick that coating is and what the adhesion is. How well is that existing coating system sticking to the steel and to itself, right? But again, also the thickness. Those are two major components that you have to think about when you're thinking about overcoating. So yeah, was it abrasive blasted before? Is there zinc primer on there, right? So there's a lot of factors that go into it, and that's what happened. A lot of times designers put out a spec overcoat thinking, well, it looks pretty good. But again, I've always told people, you can look at a system from down on the road and look up at it, right? And it could look great, but once you start playing with it, it could fall apart and that system's just dead because it's been on there 30, 40 years. It may visually look good, but a lot goes into determining should this be a total removal or if you even want to consider overcoating. But just remember one thing, overcoating is a Band-Aid, right? You're going to get a few years out of it. You might get lucky, get 5, 6, 7 years. You want to make sure you look at your system and you want to make sure you ask yourself several questions. One of them, are you going to replace the bridge in 10 years, right? So a lot of factors go into it when you want to think about that type of situation.
Thanks.
I have one quick question about the environmental. Was the environmental concerns and what stopped you, was there testing of the wash water? Was it just basically in principle that they said, no, you can't do that? Because there's been some other states in the West that did do some testing of the water and things, and they were actually allowed.
It was pretty much,
Washington State.
It was pretty much capturing the water afterwards.
Okay,
Capturing the water and then treating it and then releasing it back into the environment. That's pretty much what was going to be costly for us. Was pretty much easier or cheaper to just wait a while and then repaint the bridge.
Okay.
Basically, just containing the oversplash and the water, and then, like I said, just capturing the water after you wash and treating it.
And so you were forced to treat it because there was enough contaminants in the water?
They wanted us to treat it period. It's like
And that's what I was curious
a lot of
whether-
our bridges are weathering steel, which they don't have paint on them at all, but they wanted us to do that. Capture the water and test it and then release it and all that.
Yeah.
So
I was just curious because I know there have been some states that have.
that's basically what it was in our case. It's just capturing the water and treating it before
Right.
releasing it or putting it, taking it.
And maybe you want to
discharging
just
it.
flush it with lots and lots of water, and then there won't be enough contaminants in there. No, I'm just.
Our
thinking.
argument was, well, if
I'm
when it
sounding like
rains, what do we
Ben.
do when it rains? They're like, well, that's an act of God. We said, when it rains, it washes the bridge. Why not? When nobody's capturing the water, they don't want to hear it.
But I do, and to the contractor, that was a really, really very good comment about cleaning out the drains and cleaning out your troughs and things, because, yeah, it's amazing how much is in there. They don't work right.
No?
So.
Any other questions? All right. Well, the panel actually has come up with a couple questions. I asked everybody to provide me with a question or two that we can ask of the owners in the audience. There's a couple of good ones. One of them is, how do owners determine the project duration for cleaning and painting projects? So how do you as an owner say, well, this bridge is going to take 300 days or it's going to take 200 days? What thoughts go into figuring out how to, predict what the duration of that, or estimate the duration of a project? If anybody wants to talk about
I guess
that.
in our case, we do like a lot of institutional knowledge. You're as old as I am and been around as long as I have. You've seen every bridge being painted. So I do use that. But besides that, it's like a 3-step process for us. I go, discuss it with our construction folks. I say, here's what we're doing. They look at it. You need that many. It takes that long. And then third and final process We have a firm that we rely on. They do a lot of CMI and construction-related services. We send her the schedule of prices with the breakdown of the lump sum items, and she come up with a duration for us. So we look at it, and if it's reasonable or not, we just we'll include that in the IFP. That's how we come or settle at a duration.
Okay.
So basically what he said, like when the guys that have been here for a long time, they've kind of seen it and they had a good idea of how long it would take. Unfortunately, when they left, that knowledge left with them. So actually what I did when I started putting these together was I had went out with the inspection crews and just watched what they did in a one-night time, counted how many guys they had on site, what equipment they were using, and I correlated that to a square foot of productivity per person, per day. So, or per shift, so to speak. So, it's probably not spot on accurate, but it's roughly 500 square feet per person per shift. Is depending on the structure and like what they're doing or whatever. But that's kind of how I've been estimating my time, and I got to say that I've been relatively close. I'm within a couple days at most on each structure. So. We're tweaking it as things change, and but that just gives us a general idea of how we're coming up with our time estimates, and we always like to maybe estimate a little bit extra time if need be, just in case things arise that we weren't necessarily anticipating. But that's how we've been doing it.
All righty. And another question, how do owners go about establishing an engineer's estimate for budgetary purposes when historical data shows such a fluctuation in bid prices for similar type projects? So if either you guys or anybody out in the audience want to address that, how do you guys do an engineer's estimate for projects?
Yeah, this one can be tough, especially in recent years with how much things have inflated, but basically, we take historical data on bid prices that we've received, and we try to project what we think the inflation on those bid price items are going to be. Also project what we think the contractor is going to want to make in profit, and we base our pricing off of that.
That was my question, actually. Actually, that was my question because at some point we were doing that, going with historical data, and the bid prices were coming much, much, much lower than that. So here we established this high engineer's estimate, tying up the money, and then the low bid prices were coming at like half of the engineer's estimate at some point. We're like, and then when we would use half, the bids would come in higher. It's like for a period of like between 2010 and 2018, we did a lot of painting projects for our workhorse bridges, and that was the case. If I go with the going rate, then they're coming lower. If I go with the low rate, we're coming higher. It's like it was like really driving us crazy. It's like we couldn't pin down a cost for cleaning and painting bridges. It's like it is tough when dealing with a limited budget and try to split up the dollars between painting and fixing bridges and all that. So I was wondering if anybody has any idea on why. I mean, it was like I said, with fluctuation up to like 50% between the bid price and the engineer's estimate.
And sometimes I wonder if it's not the timing, right? When you put out projects in the fall for the following year, you're going to get probably better prices because contractors are hungry, right? And then you put out a contract in the second quarter of that same year, prices are going to go up because maybe they've got enough work and they're figuring, well, you know what, we'll shoot up a high price if we get it, great. If we don't, we're good for that year. I don't know, again, if anybody else in any other states has any thoughts on those, please, you can stand up as well. Guys are good? All right. And another one, what can be better addressed in a project specification? Oh, did you have a question? Oh, there. Okay, I'm sorry.
What's that?
I was wondering.
My
Just kind of
thoughts?
curious why the contractor
Yeah,
is
you
smiling
answer-
about
answer
that
it.
discussion.
I should've said something. I wouldn't quickly say you wouldn't.
No, it's okay. No, I mean, look, prices do fluctuate, and not just in the bridge painting world, I don't think. I think it's just in any industry, honestly. You know, it does have to do with timing of the job coming out, obviously, just like anything. Your backlog of what's going on, and just keeping things going. But I mean, personally, myself, I don't like to think we're the contractor that, you know, just bids a job at a lower number because I need a job, or at a higher number because I don't want a job. I'd like to stay as consistent as possible. At least I, you know, think that's how we operate on our end. But again, it could be many factors for certain people. You know, bidding strategies, I don't know. I mean, in our world, we have structural steel. We all have production rates, right, of how much each guy can blast a day, paint a day, rig a day. There's no way there's another company out there like ours that has manpower that is doing it 5 times faster than us. I mean, we all pull from the same type of people, you know, so we all have the same breed of construction workers, you know. So it all boils down to we have an average rate of what we can produce. And I guess what do you want to make, right? So as a contractor, you know, and other people have different types of overhead too. Overhead, the labor rates could be different well, you have prevailing wage rates, but depending on if you're union or non-union, depending how you're classifying, you know, putting your people in. Other people have EMRs, you know, based on their workers' comp. Depending on their safety records, they could have higher EMR rates, which could force them to multiply their rate, you know, their wage factor for higher, and then now they have a higher price rate because it costs them more money to perform that job than the other guy. So many different factors. I don't know.
Yeah. All right, and I thought this was a great question, and Mike, you asked this. What can be better addressed in a project specification that would alleviate some of the unknowns that contractors have? Basically, alleviate claims, right? You know, kind of be proactive in a sense. I personally like that question because I do talk about that a lot myself with many owners, but do either of you, when you put out specifications, again, or anybody in the audience that's an owner, do you think about those things, and what can we do to address this to maybe, you know, lower the chances of claims happening? Does that go into your thought pattern?
Yeah, so I think that was like a really big thought process for us when we were actually rewriting our spec, just because I had mentioned in my talk that, you know, ambiguity in a spec can be an absolute nightmare when you actually get to, you know, building a project, because, you know, if you have one thing in mind and the contractor has something completely different in mind, then it might not be what you want, but, you know, at the end of the day, he's there to make money, and he's going to do it the way that best suits him. So some of the things, I guess we're still learning on ways to, you know, to avoid claims, but in my thought process was just being extremely direct and establishing basically like a process of how we wanted it, and you know, where you wanted the project to go. So it was, our spec reads very specifically for, you know, for things that we would want. So it's, you know, kind of eliminating any of that ambiguity, so to speak.
With us, I would say, like, there are a lot of factors that affect that, like access to the site, to the bridge. You got to be very clear, and you got to make sure that you clarify access. If there's railroad, if there's private property in the way, you got to make sure you get all kinds of agreements you need before you put the job out. A big factor is maintenance of traffic. You got to make sure that you specify what maintenance of traffic, when they can get a lane closure, when they can get a lane closure, and be very, very specific. When we painted the suspension span at the Bay Bridge, we paid dearly for that because we told him he can have a lane closure and he can work on the suspension towers above the roadway 24/7. And when we put that job out, so one guy at or some big guy, a big shot at MDTA didn't want him to work in the daytime. When they had the chance to review the specifications in the book, and they said, no, you can only work at night, and that cost us millions of dollars just for making that one change. When they had the chance to tell them, no, you can work only at nighttime. A lot of times we say, okay, you can get a lane closure, and when they go out there, no, you can't get a lane closure, so that's a source for delay claims and what have you. So you got to do your homework. Like I said, a lot of access, especially dealing with the railroad. If you don't get your agreements in place, with the railroad, and there's a railroad, you're gonna have a lot of, there'll be a big obstacle in the way if you don't clear that. Maintenance of traffic is another one too, so.
Yeah, to kind of piggyback off of that, we won't even release our contracts until we have, you know, what we're going to do for maintenance of traffic in place, and that is all provided in the contract itself. So if, you know, if you can only use certain typical applications, or if, you know, a full detour is needed, all that is provided in the contract documents in which the contractor will be bidding on. So all that's known up front, and I think, you know, having a plan set forth up front is really big. And like for the railroad agreements, we also would not release a contract until that railroad agreement is in hand, if we have such, you know, such things. What was that? I'm sorry. Usually like 6 to 8 business years.
And that's if everything's
you end up
smooth.
paying for it more than whatever the job you're doing cost.
And just to add, the devil's in the detail, right? It all starts with assessing and designing of that specification. And if you put more detail into your specification so that contractor knows what they're bidding, every bridge isn't the same, right? You're going to have inaccessible, hard to reach areas. If you can detail those type of things either in the plans or in the special provisions, so when a contractor bids it, they know we're going to have these areas. I think it was either New York State DOT or New York City DOT has a part in their specification that talks about inaccessible and hard to reach areas, and they actually define it, and they also require the contractor, as part of their submittal package, to submit how they're going to address those areas. So right off the bat, you as an owner are going to know in these areas, this is what the contractor is going to do. These are the steps they're going to take to do the best they can in those type of areas. So it's details. The more details you put in your specifications, I believe claims go down, you get a better job, and the contractor is aware of all aspects of those structures that they're working on.